Welcome to Module 1 of INST728E about setting up your environment. In this video, I'll be talking to you about installing Anaconda, which will give us access to Python in a consistent way. And then from there, all the rest of the course will build on this environment for doing our analysis. So first, though, why Python? So why are we doing this in Python? Primarily because Python's easy. It's a relatively easy language to pick up if you already know another programming language. It has lots of packages devoted to all kinds of different capabilities, from interacting with other programming languages like Java or R, to doing text analysis with the Natural Language Toolkit or GenSim, to plotting with Matplotlib. Many packages that give it a lot of flexibility. As a result, it tends to be very good for rapid prototyping, so it's a nice language to rapidly go through and extract hashtags or see what kind of URLs we can pull up from social media data, or connect to social media APIs to collect data. It has a lot of capability for that. In addition, while Python is not the fastest language in the world, it can take a good bit of time to parse through a bunch of social media posts, for instance. It has a lot of recent work that's made it much faster. We're not going to get into that in this course, but a follow-on course may look at that, or there's another course in INST, in the INST curriculum that looks at this, where we can use Spark and its Python backend called PySpark, or we can do Python or some of these other packages and platforms that make Python a lot faster. All right. So that's why Python, but why Anaconda? So Anaconda is essentially a package around Python that gives us a portable and consistent environment. So when we install Anaconda, which I'll walk you through in the next few slides, it gives us a new installation of Python and R, if you want to use R, along with the ability to install our own packages without interfering with any packages that are already installed on your system. So it doesn't matter if we're using Windows, Mac, or Linux. If we install a new version of Anaconda, then we can start from the same baseline of the same packages, the same package versions, and all these different things. So it's going to make things a lot easier for us. And then secondly, Anaconda has some nice capabilities for sharing environments. So what does this mean? This means that I can set up Anaconda on my machine with a certain number of packages for doing natural language processing, connecting to Twitter, connecting to Facebook, connecting to Reddit, doing all these different things. I can set all of that up on my laptop and then export that descriptor of that environment. And you can download that descriptor and set up a duplicate copy of my environment on your local machine. So we'll do that as well. So we'll all have the same packages, all the same package version, all that kind of thing. So we'll have, all of us will have a consistent environment where we can do our analysis. So even if you have Anaconda already installed, go through these directions anyway. There'll be a part where you will add a new environment, and that's where you're going to want to start paying attention if you already have Anaconda installed. If not, no worries, we'll go through it now. So the first thing to do is to get Anaconda. It's a relatively large package, so you might want to do this at home or on campus where you have a nice high performance or high bandwidth link to the internet. But to get Anaconda, all you have to do is go to anaconda.com and look for the download button. And then from there, you can choose whichever distribution you want or whatever distribution you're running. So if you're on a Mac, you can download Anaconda for Mac or for Windows or for Linux. So I'll go through the installation procedure for both Mac and Windows pretty quickly. They're very similar. So once you select the distribution you want, just scroll down, and then you'll see a list for Anaconda 5.0.1 for whichever interface you want or whichever platform you're on. So I guess it's this one, it's the Mac one. The most important thing you do is select the Python 3.6 version. So don't select Python 2.7. There's some differences in syntax for Python version 3 versus version 2. So we'll do Python 3.6. Same thing for Windows. You just scroll down, hit the Python 3.6 version, not the 2.7 version, and then you'll start downloading this file. For Mac, this will look like a package file. So you just double-click that in your downloads directory or wherever you had it, and it'll come up with this Anaconda 3 installer, and you just follow through the steps. The main thing to do is when you select the destination, the easiest thing is to select Install for Me Only. This will install Anaconda 3 to your home directory, and you won't have to have administrator privileges or anything to do this, but it will take a good bit of space on your hard drive. So once you do that, you'll wait for some amount of time while the installation goes through its process, and then at the end, you should have in your home directory, like I said, a file or a folder called Anaconda 3 that you can open up. The main thing to look for is the Anaconda Navigator.app file. In Windows, you do pretty much the same thing. Once you've downloaded the Anaconda installer, you'll have this executable file. Just run that, and then go through the steps for installation. Same thing when it asks install for just me or all users. Go ahead and install just me. You can do all users, but for simplicity, I recommend the just me option. And then, as before, go through the steps, and we'll wait some amount of time for it to install all the packages that come with Anaconda. So Python, R, Matplotlib, all those will be downloaded for you. And at the end, if you go to your Start menu, you should see a new folder for Anaconda 3. And under there, you should see the Anaconda Navigator icon, just like we saw with OS X. All right, so that's all about installation. Once you've done that, you're pretty much good to go. The next thing to do is to open the Anaconda Navigator application. This will be the main interface we'll be using to launch Jupyter Notebook that we'll talk about in a few minutes. So for new installations, you'll get this "Thanks for installing Anaconda" message. You can click OK or don't show again or whatever, but get rid of that. And then the main thing that we're going to be using is this Jupyter Notebook package. Do not click the Launch button yet. We need to go do some additional configuration, but assuming that you have that little panel for Jupyter Notebooks, then you've at least got the initial environment set up. The next thing to do, though, is to configure Anaconda. So what this means is use the environment file that I'll provide to set up a duplicate environment of the one I have on my laptop, so you can follow along with all the analysis that I'll show you over the course, or over this course. All right, so if you bring up Anaconda Navigator, it should look generally like this, regardless of whether you're using OS X or Windows or Linux. What you want to do is click the Environments button on the left. So the Environments button will show you the different environments that we have access to. We can create ones, we can create new ones, we can clone existing ones, we can delete ones, we can import ones. We'll use the import button in a second. But first, that panel on the right with all the different names and descriptions, those are all the packages that Anaconda comes with by default. But what we're going to do is import a new environment from a file that I'll provide. So go ahead and click that import button. You can put in the environment name, INST728E, and then it needs a specification file. So to get the specification file, you need to go to Elms and download in the resources directory. There are a couple of files that you can choose from. If you're using OS X, then you want to download the INST728E osx.yml file, so it's called a YAML file. If you're using Windows, then download the _Windows YAML file. If you're running Linux, I didn't put together a YAML file for you, but if you look at this slide or check out this PDF in Elms, then you can run all of these installation commands from your command line, and that'll give you a duplicate installation as well. But if you're running Mac or Windows, don't worry about this. Okay, so once you point the specification file at the YAML file that you downloaded from Elms, then it'll start, or Anaconda should start creating this environment for you. So you should see a new environment show up in the left panel called INST728, and then you'll see some messages down at the bottom on the right panel telling you what packages are being downloaded. So this is going to take some time while it downloads, Jupyter Notebook and Matplotlib and everything, or copies them for you into your new environment. So wait for a few minutes there. Once you're done waiting, at the end you should see a screen that looks close to this, where you have your INST728 environment with about 100 packages installed that include Basemap and Jupyter and these kinds of things. And now we can talk about how to start it up. So the important thing is that you select the INST728 environment. So that means you need to click on it and make sure that there's that triangle or that play button to the right of it. If the play button is to the right of root or some other line in this panel, that means that environment is activated. And we want to focus on the 728E one because that's where we have all of the packages for our analysis. So click to activate this new environment. And now we can talk about testing it out. So if you click on this triangular play button, even after you've activated the environment, it'll give you some options. Either open a terminal, open with Python or IPython. We want open with Jupyter Notebook. So once you click that, then if you're on Windows, you'll see a black screen pop up with some messages on it. If you're on OS 10, you should see a white screen that looks similarly to the one that you see here with some information on it. And in either platform, your default browser should pop up with a screen that looks kind of like this. So if you look in the URL or what the address is, it'll say localhost and then some 4-digit number that should be close to 8888 and then /tree, and you'll see a bunch of directories that generally represent your home directory. So if you're in OS 10, it'll have like pictures and downloads and such. Same thing with Windows. All right, so now we need to download the notebook file that we'll use to test to make sure that your environment creation worked out well. So go to Elms and download INST728 mod01 package testing.ipynb. That stands for .ipython notebook, and save that file wherever you're going to be saving the rest of these notebook files for the class. Once you've got that downloaded and saved somewhere, preferably somewhere in your home directory or in one of these subfolders in your home directory, go ahead and navigate to that. So for me, you might go to documents/INST728E, and then you'll see a window like this, let's see, without all the other modules, since this is all the modules that I have. And then click on the package testing module 1 file. Now you should have a new window pop up that looks like this. So INST728E homework 1, so that you'll actually you'll run this file and turn this in as your homework for module 1. So there are a couple things to note about this window. The first is the play button up here at the top. So that's what you use to essentially run one of these cells. In the next module, we'll talk more about what Jupyter Notebook actually is and how to interact with it. But for our purposes, the main thing we need to focus on is running each one of these cells. So if you see a wireframe bar around a particular cell, that cell is your currently focused cell, and you can go ahead and click run a few times to run these files. Now, as you run through all of the cells in this notebook, you may get some of these pinkish boxes that have a user warning. That's fine. So this is to be expected the first time you run an import that imports Matplotlib, which is a common graphing library that we'll talk about in the next couple of modules. It'll come up and give you a warning saying it's going to take some time to build the cache for this package. That's fine. Don't worry about it. Ideally, you shouldn't see any message pop up except for these pink warning messages, and you should only see 1 or 2 of those. If you see a message that says module not found error, like the one here, that's a problem. That means that for whatever reason, one of the modules that was supposed to be installed was not. And if that's the case, just let me know and we can work through it. If you went through and ran everything though, and everything worked without error, then you should be good to go. If not, like I said, don't worry. Just post on Slack and send me a message, and I'll work with you to get everything fixed up. All right. So for the Module 1 homework, like I said, the main thing to do is to update to download this notebook, run it, update this cell here where it says my name and email. Just go ahead and put your name and email here, and then we'll run it. It's just to make sure that you actually ran this, and then you can submit this to ELMS for homework 1. If you want to look for some additional resources, there's a quick intro to Jupyter Notebook YouTube video. It's about 7 minutes long. You can go through and view it. I suggest you go through and watch Module 2, this next module on the Jupyter Notebook before you do this, but feel free to check this out as well. It's a relatively good and quick introduction. All right, so now I'll switch over to the Jupyter Notebook example, and we can step through that really fast. So like I said, you should go to wherever you had the package testing notebook file that you downloaded from ELMS, and just click on that, and a new tab will open. If you wait a second, it'll say kernel starting and then kernel ready. This little empty white ball here says that the kernel is idle, so you can start running things. And then, like I said, we're in this cell now. So what we want to do is click this run. I'll go ahead. If you double click in the cell, you can edit it. So you can change these things. Right? So you can click run, or you can click shift and enter together, and that will run whatever cell you have focused. And then for these cells that have just text, it won't do anything. These are called markup cells. We'll talk about that in the next module. They're just for documentation and telling you what's going on. So we ran this first one, and we ran standard libraries. We'll go through and run matplotlib. All these imports for matplotlib, which is a graphing library, numpy, that's generic numeric computations for Python, and then pandas, which is a nice data frames package for doing data analysis, so we'll run that. Again, if everything worked out, you shouldn't see any error. Maybe you'll see a warning here, but that's fine. And then we'll do this for everything, so requests, we need to make sure that that's there. Facebook, PRA, and Tweepy for interacting with these platforms. The base map package lets us graph maps. We'll see that in Module 7, I think. Scikit has a lot of text processing and machine learning capabilities. Let's see. All of these NLTK things have some more text processing, sentiment analysis, tokenization things. We'll talk about that. An important thing here is, so if you go ahead and run this, you'll get this warning about Twython. That's fine. Don't worry about that. This next cell for where it says nltk.download, we need to run these two things that'll download the stopwords corpora and Vader lexicons, which we'll use for Vader we'll use for sentiment analysis. Stopwords lets us remove very common words in different languages. So go ahead and run that. For me, I've already run this, so I've already downloaded these files, but you should have a new directory show up in your home directory called NLTK data, and these stopword and Vader lexicon files will be downloaded to there. So an important thing to note is you need to have internet when you run these .download functions. All right. Then TextBlob and GenSim are a couple other text analysis libraries, and then finally NetworkX. Assuming that everything worked well, you should have this empty cell here where your cursor is blinking, and everything should have imported correctly without error. You can do things more quickly if you click cell and you click run all. Then all of these things will get run. You can run them again. It's no big deal if you run these out of order or run them multiple times. That's fine. The only real ordering constraint is you have to import NLTK before you use NLTK.download. All right. Well, that should be it. If you run into any problems where your kernel hangs up or something, you can click kernel and do interrupt, or press this stop button right here. And you can always do restart and clear all outputs. This will come up with this message. And once the kernel restarts, all of your output will get cleared away. And that's it. So when you are done with this, just save it. So you can click this save icon here, and then you can save the IPython notebook and then upload it to Elms as homework 1. All right. If you have any questions, feel free to post on Slack.